How to create a rubric for science experiments. Have you ever wondered how to create a rubric for science experiments that truly support student learning? Let's break it down step by step to make it clear and effective. First, start by analyzing the assignment and defining its purpose. Think about what skills or knowledge you want your students to demonstrate. Are they forming hypotheses, conducting procedures, or analyzing data? Also, consider if the rubric is for formative feedback to guide improvement or summative grading. This step helps ensure the rubric aligns with your teaching goals and clarifies what you expect from your students. Next, select the type of rubric you want to use. You can choose between an analytic rubric, which breaks down the assignment into multiple criteria with separate scores, or a holistic rubric, which gives an overall score based on general performance. For science experiments, an analytic rubric is often more effective. It allows you to assess specific skills like experimental design, data collection, analysis, and conclusion. Now let's identify and define the assessment criteria. List the specific criteria that reflected important aspects of the experiment. Common criteria include hypothesis formulation, experimental procedure, data collection and presentation, analysis and interpretation, conclusion, and scientific writing quality. Make sure each criterion is described clearly and in student-friendly language. Avoid vague terms. Instead, specify what you mean in context. For example, instead of saying clear, explain that a clear hypothesis states a specific, testable prediction. Then define performance levels for each criterion. You might create levels like excellent, proficient, needs improvement, and unsatisfactory. For each level, describe what student work looks like at that quality. For instance, under data presentation, an excellent level might say, all data is accurately recorded with correct units and clearly organized in tables or graphs. Meanwhile, needs improvement might say, data is incomplete or missing units. Incorporate scientific vocabulary that students have learned, such as variable, control, unit, and observation. This reinforces their scientific literacy. Use the language from the rubric during instruction and formative assessments to help students understand and perform better. For example, reminded students to include units or explain variables as per the rubric criteria while they work on their experiments. After you have created your rubric, test and refine it. Try it out on sample student work or a pilot assignment to see if it effectively differentiates levels of performance and covers all important aspects. Gather feedback from colleagues or students to improve clarity and fairness. Finally, share the rubric with students beforehand. Providing the rubric before they start the experiment helps them understand your expectations and allows them to self-assess their work during the process. As an additional tip, consider involving students in co-creating or reviewing the rubric. This can increase their engagement and ownership of their learning. Avoid filling every box with descriptions if you want to encourage students to exceed expectations. Use the rubric not just for grading but as a teaching tool to guide students toward higher-level scientific thinking, such as constructing arguments and reasoning based on evidence. By following these steps, you can create effective rubrics that clarify expectations, support student learning, and streamline grading for science experiments.